So now, do you guys want me to just go ahead and solve the problem straight through, or did you guys want to make it a little more interactive and I can stop and ask you guys questions and you can help me solve it? All right, cool. We can make it more interactive then. All right. It might work better if you guys have the microphone on to make it interactive, but we'll see how it goes. All right. And then just a heads up, I'll go ahead and post my notes um after we finish the review session. That way, you guys can look over my work. Yeah. All right. So problem 4.107 is the one that deals with the truck that delivers food and supplies to the airplane. So kind of looks like a scissor lift, like this. And there's a platform at top. And there's a weight on it. So the problem says, let's see, that the weight up here is 2,000 pounds. And then it's also kind of hard to see, but I noticed that on the left-hand sides we had simple supports, so um, represent them with these triangles. And then on the right-hand side we had roller supports on our scissor lift. All right. So let's go ahead and we can make a free body diagram on the next page. Or we can go ahead and make it over to the right hand side. So let's see. So my first thought was we were going to make a free body diagram of the whole body, um, like of the whole frame structure. And from that, we'll be able to get some forces. Um, and then from there, we can break it down. Because eventually what we want to do in this problem is there's a, a piston here, and it's applying some force. And we're trying to figure out what the force in that piston is. Um, but first, it'd be helpful if we knew all the reaction forces at these supports. So by looking at a free body diagram of the entire structure, we can at first neglect the force in this piston and just figure out the reaction forces. All right, cool. So I'll go ahead and make a free body diagram on this page. So let's see, we have this guy. All right, let me label the points. So we have point C, D, F, and H. So now C and F are the simple supports. So what kind of reaction forces are we going to have at C and at F? So F, if you remember back here, F was a simple support, and same with C is C. This is point C, so this is C, D, F, and H. And so C and F are the simple supports. So we're just going to have force in the Y. But then what about D and H? Those are just a simple, the roller supports. So what kind of forces do you normally see out of a roller support? Right, yeah, we just see the vertical forces from our roller supports. All right, so we have a roller support here and one here. And F and C, we have vertical forces, so I'll call this Fy, and then I'll call this one Fx, and then over here we have a vertical force. We'll call this CY, and we'll call the other one CX. Cool. Okay. Now we also have the weight. That force is acting on this little structure. So our weight is equal to 2,000 pounds, and we're going to put it right here in the middle. That's W. W equals 2,000 pounds. We put it in the middle because on the problem, it's located at point G, and point G is directly above this middle point here. So that's why I went ahead and put it there. All right, now let's see. We have how many unknowns? We have 1, 2, 3, 4, 5, 6. 6 unknowns. That's quite a lot. I don't think this problem is in the text. There's a similar one though. Let me take a look. the problem that looks like it is problem 6.1, 6.110. That one, though, still has a hydraulic piston on it, but it's acting at a different point. So it's slightly different than that. Yeah. Chapter 6, problem 110. AB is a two force member, and it's right here. But since we're not removing it from our structure yet, we can still consider it as part of our frame. Does that make sense? Oh, why is it not a 0? Um, well, AB, the piston there is what's preventing the scissor lift from moving down. Um, so if you removed AB, then the scissor lift would just collapse because point H and point D are just rollers, so they would just continue moving right, which makes the whole thing move down. And if it is a two force member, it can still have a magnitude, yeah. All right. So right now, what did I say? I said we had 6 unknowns. And this is a little tricky. So I just wanted to show you that sometimes breaking it up, even just as breaking it up this way, doesn't work out. So yeah, because we have 6 unknowns, and basically we'll only have 3 equations, so we're not going to be able to solve it completely. So I'm going to make a new free body diagram and show you a different way to approach the problem. So now, basically, if you take the structure to include that platform that's above C and D, then you don't have any reaction forces at. You still have the reaction forces at point C and point D. Um, point C and point D are here, but we're not including them anymore because now they're internal to the system. Because now our system is this entire thing, whereas before we cut our system off here where the supports were. So do you guys see that by choosing a different free body, um, then we can eliminate the forces at C and D? They're not disappearing, they're just disappearing in our calculations. Anyways, so with this simplified body that we just made, we still have the reaction forces here at Fy and Fx, because we're still kind of cutting our structure at the pin supports, so we still have the reaction forces acting at F and H. So we still have our vertical forces here. That's H. And then this platform, we still have the weight acting on our platform. And this weight is 2,000 pounds. All right. So what we're gonna do is we have right here we have 3 unknowns, and we're gonna be able to get 3 equations. That way we're gonna be able to solve for Fy, Fx, and H with this free body. So I'll go ahead and start a new page, and we can go ahead and solve these out. All right. So let's see. Some of the forces in the x, that'll be our first equation, equal to Fx, and we have no other forces acting in the x direction. So we see that Fx is just going to equal 0. Some of the moments about, let's choose point F. And we have, let's see, W. We'll say that W creates a positive moment, and it is 57 inches away from point F. And then what about H? H is going to create a negative moment, and it is 114 inches away. And our moments sum to 0 because we're at equilibrium. So now we see that a half a W because 57 over 114 is just 1 over 2. And you can see that because the weight's applied at the middle of the point between F and H, or it's the middle between C and D. So we know that uh, it's just half the distance. All right, so it's half a W is equal to H. So that means that H is equal to 1,000 pounds. And then our last equilibrium equation, we'll go ahead and do some of the forces in the Y. And this is going to equal, let's see, Fy plus H and then minus W. This is going to equal 0 because we're at equilibrium. So from here we see that Fy equals W minus H equals 2,000 minus 1,000. Oops, 1,000. So now Fy equals 1,000 pounds. All right, cool. Now, let's see. I'm going to go back a couple pages. So we use this kind of simplified free body diagram to figure out the reactions at F and H while neglecting the reactions at C and D. Now, if we come back here, um, we know Fx, Fy, and H. So now, using this free body diagram, we have 3 unknowns. So we're going to be able to solve it if we want to. So I just wanted to show you guys that sometimes you can come back and use a free body diagram later on once you figure stuff out. All right. So like I said, we have H, Fy, and Fx. All right. So what equation do you guys want to use first to figure out one of the forces that we need to find out? We can do some of the forces in X. I'm not sure what you mean, eliminate Fx. We know that Fx equals 0, so we can use that to find that Cx equals 0. Is that what you were trying to get at, Jimmy? All right, awesome. I'm gonna go ahead and just write this on a new page so we can, I'll have room. So again, we have Fy, H, Cy, C, or this is point D, um, Cx, Fx, Fy. Also, I think I made a mistake earlier when I said that W, that the weight should be on here. In this free body diagram, we're not including the weight because the reaction forces at C and D account for the weight. So as Jimmy was saying, take some of the forces in the x, and you see that's equal to Fx plus Cx equal to 0. Well, Fx is equal to 0, so Cx is equal to 0. Awesome. Next up, I would say let's use the sum of the moments equation. So where should we sum the moments about to quickly get something? C or D? We can go ahead and do All right, so we'll go ahead and say sum of the moments about C. Let's see. We'll go ahead and see that. So the forces at C don't create any moment about C. Fy passes through C, so that doesn't create any moment. Fx we said is 0, so that doesn't create any moment. H, that was this force. We'll say that H creates a positive moment, so we'll have H times, let's see, that moment arm was 114 inches. And then what about D? Well, D is defined in the opposite direction, so it would create a negative moment. And lucky for us, it has the same moment arm of 114 inches. And this is equal to 0. So pretty easily we see that the force at D is equal to the force at H. So they're both equal to 1,000 pounds. Awesome. Okay. Um, Next up, we can go ahead and do some of the forces in the Y. Well, I guess we have two options here. We can do some of the forces in the Y to figure out that Cy is equal to 1,000 pounds, because H and D are equal to each other, so Fy and Cy are going to have to be equal to each other. So one way of doing that is by using the sum of the forces in the Y, or another way of doing it is taking the moments, this time about point D, and it would give us the same thing, the same result that Cy is equal. I'll go ahead and just write it out this way. Sum of the forces in the Y equals Fy plus H minus D minus Cy equal to 0. Cy is equal to Fy plus H minus D. We know that H and D are equal to each other, so they cancel each other out. So Cy is equal to Fy. Cy is equal to 1,000 pounds. Cool. All right. Any questions so far? Nope. Okay. I'll keep moving forward then. So we're still trying to figure out the force that piston AB has. So we'll go ahead now and we'll take a look at just one of the bars in this. So if we're looking at the beam that goes from C to H, looks like this. Has a pin support up top, and it's got a roller support at the bottom, and it's got point E here, and point E is what connects this beam to the other beam of the scissor lift. And then we also have the piston which connects here at point A. Alright, so free body diagram for this guy looks like we have Cx. I'm going to stop writing Cx since we know it's 0, so we just have Cy. We have H over here. We have Ex and Ey. And this is just the pin reaction forces that because this pin connects this beam to the other beam which goes from point F to point D. And then we also have the force which comes from that piston. We'll just call this force B. Alrighty. So all we need to do is find force B, and then we'll be done with this problem. So I suggest the quickest way to do that is just by taking the sum of the moments about a point. point E would be the quickest for finding out. Oh, okay. Sorry. You said my mic is going out, in and out. I can make my mic louder. I turned my mic all the way up. Does that help at all? Awesome. All right, let me know if there's issues with it anymore. All right, what I was saying though is that we're trying to find the force at B, and then we're going to be done with the problem. So I think that the quickest way to do this would just be to take the sum of the moments about E, because we don't know the forces at E, but we don't really care to find them. We just want to know what B is. So if we do this, sum of the moments about E, we'll be able to quickly find the force at B. All right. So some of the moments about E, we have CY, moment arm of 57 inches, creates a positive moment. And then H is going to create a moment that's also positive, moment arm of 57. And then B is going to create a moment in the opposite direction, so that's minus B. Its moment arm is 17 inches. And all of these are going to equal 0 because we're at equilibrium. Alrighty, now all we want to do is solve for B. So we say that B is equal to 57 times CY plus H all divided by 17. Let me plug this in the calculator to make sure we're getting the right answer. So we get 57 times BY, or CY plus H is 2,000. And we divide it by 17. And I get 6,705. And I think the answer that's attached to the problem and the handout says that B is equal to 6,710 pounds. So I think our answer is pretty close. All right. Any questions with this problem?